Hey class, I missed you guys, I really do. It's Mr. Klausner here from the classroom. I'm now at the desk in the back here. I just want to say I'm going to go over a couple examples for this week. April 13th, I'm going to go ahead and put it out on Monday so that you guys can work on it. Technically there is no school because we're not supposed to be in class on Monday, but it's due on Friday, so that might give some of you that extra day to work on it. So last week we worked on one-step equations, and this week we're going to work on the same thing, except now we're going to have coefficients. That means the number that becomes before the variable, like we reviewed last week, coefficients that are either decimals or fractions. So an example that we have here is 16 is equal to 0.25n. Okay? So we want to figure out what is n, what is a number that is multiplied by 0.25 that's going to equal 16. So it's a little tricky, but again we need to isolate the variable, meaning we need to get n all by itself. So to do that, I'm going to divide by 0.25, 25.25. So now whatever I do to the right side, I'm going to do to the left side because of reciprocity. So when I do this, these are going to cancel, okay? Anything divided by itself is 1, so now I have 1n on the right side, and I can go ahead and solve 16 divided by 0.25. So let's do that. We can do that long ways. Gotta think to myself, move the decimal point. 25 goes into 160. 25 times 6 is going to give me 150. What's left over is 10. I bring down this 0. You guys can see that. Okay. And now I think how many times does 25 go into 100? Well, that is 4. And look at that. It works out nice and neatly. So when I look at myself, what was I solving for? Well, I was solving for n. I was looking for a number that times by 0.25 is going to equal 16. And if I plug it back in there, 64 times 0.25 equals 16. I can pull up the calculator here. You guys can see that. Okay, this is example number 2. We have 6.4 equals 0.8 times m. Remember, this is times m. Times m. There's multiplication in here because they're right next to each other. So what I did in the last one, I need to do here. I need to divide by 8/10 or 0.8. Whatever I do to one side, I must do to the other side. So now I have 0.08 m divided by 0.8, which these are going to cancel. That's going to make that a 1. So now I have 1 m, or I can just write m. It's hard to do upside down, but that's all right. And now I can go ahead and do this here. I'm actually just going to plug this into my calculator. I'm okay if you guys do that at home too. So again, 6.4 divided by 0.8. Okay, just typed it in there. So now I'm thinking to myself, all right, what is the number 8 is equal to m? So 8, if I plug this back in here for the representation of the variable, m is equal to 8. I do 6.4 is equal to 0.8 times 8. And I can check my work here. 8 times 0.8 equals 6.4. Checks out. Alright, that's example number 2. Let's look at example number 3. This is fraction coefficient. So now we have 3/4 x is equal to 12 over 20. Okay. So when I look at this, what I think immediately is I should reduce this side, but we can get to that a little later. Why did I draw this in blue and this in green? Well, let me show you. So when I solve for this side, I'm going to multiply by what we call the multiplicative inverse, okay? Or you guys have heard me say it, it's the reciprocal. So in order to get rid of 3/4, I'm going to multiply it by and I think you guys know what I'm going to do with these colors. I'm going to multiply by 4/3. Okay, because that's going to go ahead and cancel these, and now I'm just left with x. Now why did I do that? Well, I know that anything times by its multiplicative inverse or its reciprocal is equal to 1. So 3/4 times 4/3 is equal to 1. Leaves me 1x, and now I've isolated my variable. Whatever I do to one side, I have to do to the other side. So I'm going to multiply it by 4/3. Okay, on the right side. All right, here's where I said I could have reduced. Now I can reduce. If you can follow along here, you can also multiply this out and get 48/60, but you can actually make it a little bit easier on yourself. How many 4s go into 20? Well, there are 5, and there's 1, 4, and 4. How many 3s go into 12? Well, there's 1, 3, and 3, and 4 12s and 3. So 4 times 1 up top, I get 4. 5 times 1 on the bottom, I get 5. So now I have solved for x. 4/5 equals x. Okay?